Hey, welcome everyone. Today we're going to talk about section 6.1 using similar polygons. We're also going to discuss some proportions as well. So essentially what similar polygons means is that we have two polygons, all the corresponding angles are congruent, and the side lengths are proportional. So really what we're doing is we're taking a figure and we're either shrinking it or expanding it. So for example, in this first one here, it says corresponding angles. You'll notice pretty obvious that angle B and angle F are corresponding, angle A and angle E, angle C and angle G, and angle D and angle H. And then of course we've got corresponding sides, BC and FG, AD and EH, BA and FE, and CD and GH. Okay, and whenever we're naming these sides, we definitely want to make sure that we name them based off of what our first one is. So for example, with BC and FG, I started with B, so I have to start with F, my other part. Reminder, anytime you have these videos, you can always fast forward, rewind, pause, so forth through them. I would always attempt the problems first beforehand, but that's totally up to you. Example number 1 in the diagram, triangle ABC is similar. Okay, that little mark right here means similar to triangle DEF. List all pairs of congruent angles. First thing that we want to look at here is what necessarily will match up. The way to determine that is based on what is said in our similarity statement. In this case, angle A is going to be congruent with angle D. Angle B is going to be congruent with angle E. And angle C then is congruent with angle F. Remember, the angles are congruent in these corresponding triangles. Okay. However, it's the sides that are the proportions. So the next thing that we want to do is we want to check that the ratios of the corresponding side lengths are equal, which means that if I was to say, like for example in the first one, I've got AB and DE that are my corresponding sides. So in this case, 25 over 35, which is 5 over 7. When I find the other sides that are corresponding, I should get the same ratio of 5/7. If I don't, that means that these triangles are not similar. If I do, then it means that the triangles are similar. So if I test the other ones here, BC and EF, okay, I get 20 over 28, which also reduces to 5 over 7, so I'm good there. And then AC over DF, which is 30 over 42, which also reduces to 5/7. So now that those are all the same exact ratio, I can write the ratios of the corresponding side lengths in a statement of proportionality. And essentially all I'm doing in the statement of proportionality is I'm taking the proportions that I used, not the 5 over 7, not what I found, but what I first started with the sides, and setting them all equal to each other. So AB over DE is equal to BC over EF, which is also equal to AC over DF. Again, if you need some help on this, please make sure to rewind the video. Scale factor. Scale factor is a name for the ratio of two lengths of two corresponding sides when two polygons are similar. Essentially what scale factor is a number that is going to help you determine, or a number or a proportion that's going to help you determine what you needed to multiply in order for one figure to go to another. So sometimes you're going to be multiplying to make the figure bigger. Other times you're going to be using it in order to make it smaller. Determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor for RSTU and DEFG. First thing that we have to do is determine if the angles are congruent, and obviously by the figure and the symbols that are shown, they are. I'm just going to write them out here real quick for you. Angle R is congruent to angle D. Angle S congruent to angle E. Angle T is congruent to angle F. And angle U is congruent to angle G. Okay, so remember that's the first part of similarity, is making sure that all the angles inside each of those are congruent to the corresponding angles in the other polygon. The next thing that we have to do is make sure that the ratios of the corresponding sides are congruent. So taking a look here and taking our time here, we got RS and DE, which is 30 over 20, which is 3 over 2. So we need a 3 over 2 ratio for all my other sides as well. So let's do ST over EF, 27 over 18, which is also 3 over 2, so we're good there. UT over GF. So in this case, we've got 33 over 22, so divide those each by 11, and I've got 3 over 2 there. And then RU over DG, which is 12 over 8, which is also 3 over 2. So I'm good there. Based on this, I can now write my similarity statement, which is RSTU is similar. And remember that similarity notation, DEFG. And we've got a scale factor. Okay, scale factor is actually the thing that we were finding with the ratios. I'm going to write it just as 3 to 2, or you could also write it 3 over 2. Usually this is what you see though, however, whenever you're looking at ratios. All right, we only got about 3 examples left here. In the diagram, find the value of x. Hopefully you can take a look at this and try this on your own. Coming back to this type of problem, if you know that these two are similar, you can actually set up proportions in order to solve. So for example, I might say that BC and XC, which is 12 over 30, is also equal to x over 40. And then you can do cross multiplication if you want to. 30x is equal to 480. Divide, and then x would be equal to 16. So now we're getting into one of the theorems. It's called perimeter of similar polygons. If two polygons are similar, then the ratios of their perimeters is equal to the ratio of their corresponding side lengths. So for example, if I find out that the side lengths ratio, like in that other example, was 3 to 2, then the perimeters would also be 3 to 2. Example 4 here, you're constructing a rectangular play area. The playground's rectangular with a length of 25 meters and a width of 15 meters. The new play area will be similar in shape, but only 10 meters in length. First off, we want to find the scale factor of the new play area to the playground. Then we want to find the perimeter of the playground and the play area. So first off, I'm going to go ahead and I'm going to draw a rectangle here. I'm going to label it 25 and 15. And then I'm also going to draw my other one here. My longest side, it says 10 meters in length. If I were to find my perimeter for this first one, just to kind of show you what I'm looking at since I'm dealing with perimeter. My perimeter in this case is 80, 25 plus 25 plus 15 plus 15. And I need to find the perimeter of the other area. So what I'm going to end up doing is I'm first going to find out what my perimeter, or I'm sorry, what my proportion is, comparing my new to my old. So in this case, I'm just going to be looking at the sides here of 15 or 25 and 10 because that's really all the information that I have. It's 25 and 10. Or I'm sorry, my new and my old. I got to switch that around. My new is 10. My old is 25. Which then is 2 over 5. So think of it this way. When you're trying to find your proportions, if you're going from a big figure to a smaller figure, you're going to have a fractional number that you're going to be multiplying by, which is going to be your scale factor. If you're going from a figure and then all of a sudden you're going to a larger figure, you're going to have a number that's a whole number because you're trying to make that area bigger. So this is my scale factor, 2 over 5. So what that kind of helps me determine then is if I'm looking at my older perimeter of 80 and I have the scale factor of 2/5, that means that this perimeter, my new perimeter, is going to be, I think 40. Let me double check my math there. I don't think I did it right. 16. There it is. So this 80 divided by 5 is 16. 16 divided by 2 is 32. So this would be my perimeter of my new play area. Now it said find the perimeter of the playground, which I did, and I found the perimeter of my new playground. Last thing that I want to do is find the play area. I'm just going to write that off to the side here. This is another way to actually find this perimeter. So I'm just going to kind of match this up. I know that this is 32, but I could also do 2/5 is equal to P over 80. And it would give me the same exact result. Give me 160 is equal to 5P. So then P is equal to 32. So two different ways in order to do that. I just did it quickly in my head, but to show you the mathematical calculations. And then, of course, it'd be 32 meters. All right, last but not least, we've got similarity and congruence. Any two congruent figures are also similar. Their scale factors in this case are 1 to 1, which means that if I took a figure, multiplied it by 1, I would get that same figure with the same measures. Corresponding lengths in similar polygons. If two polygons are similar, then the ratio of any two corresponding lengths in the polygons equal to the scale factor of the similar polygon. Wow, that's a lot. So let's look at exactly what that means here with example 5. In the diagram, triangle MNP is similar to triangle RST. Find the length of the altitude NL. First off, we want to look at those two sides. I'm going to look at the side MN and the side RS. So MN and RS. I could have also looked at the other two, but those are the two right now that I want to look at based on what I know of these two triangles in particular. So I've got 30 over 20, which gives me the scale factor of 3 over 2. How do you know what goes on top and what goes on bottom is a very good question. It's all based on your similarity statement. So for example, M and P came first, so it would go on top in your fraction. RST came second, so it would go on the bottom of your fraction. Simple enough. So now that I know that my scale factor is 3 to 2, I'm going to say that I have 3 over 2 is equal to what I'm trying to find. So I'm trying to find the length of NL. It's in my first triangle. And then I'm also trying to find the length of what it's compared to. So in this case, it's compared to 14. So now I'll have 2NL is equal to 3 times 14, which is 42. So NL is going to equal 21. Hopefully this helped you today with these notes. I know this is quite a bit. Please make sure that you do the corresponding homework assignment. And then if you have any other questions, feel free to reach out to me via email. Also, if you check the internet, I'm sure that if you type in our topic, which is use similar polygons, you'll probably find a couple videos from some other teachers, probably more qualified than myself even, to help you out. Thanks a bunch, everyone. Have a great day.